Hello, this is the Masterclass 2022 brought to you by Women Plus in Geospatial. Organized by Women Plus in Geospatial Regional Group of Asia and Sub-Saharan Africa. Our vision and mission. Our vision is forging a geospatial community where all genders can thrive. Our mission is to build an inclusive global community, uniting, inspiring, and empowering all women plus in the geospatial sector to become strong leaders and change makers. Inspire, unite, and empower. Inspire. We want to inspire women plus from all age groups and any part of the world to join or stay in the geospatial field by showcasing other women's work and successes. Unite. We want to bring together and connect a community of women plus in the geospatial industry field to support each other and become stronger together. Empower. We want to provide the tools and the platform for Women Plus to shine and grow. Regional Ambassador for Asia, Dr. Lakshmi and Goparaju. Co-regional ambassadors for Sub-Saharan Africa are Ms. Opiami Kazim Jimo and Ms. Nasilele Amantende. This Masterclass 2022, the objectives are geospatial technology, which dates back to 1960s, has been an emerging technology to study the Earth's surface and phenomenon, enabling research like daily updates, long-term monitoring, and predicting the future scenario. It has advanced tremendously in the past few years, faced transformations from simple analysis to complex big data, opening new opportunities every time and providing solution to the sustainable development goals. This masterclass is for women in geospatial enthusiasts. We aim to enhance the knowledge on various spheres of geospatial technology. Through this series, we will try to enlighten you on certain topics revolving around technology, software, conservation of natural resources, potential of OpenStreetMaps, and artificial intelligence in agriculture. The level is from beginner to intermediate level for undergraduate and postgraduate audience, not restricting to anyone who wishes to learn. Also, a list of resources will be provided for you towards the end to dig deep into the subject of your interest as per your convenience. Please do provide us feedback using our social media links, which will help us to strengthen our platform and bring in more series to enhance the capacity of Women Plus in Geospatial. So these are the links on Twitter, LinkedIn, and we also have a Slack with many members. This is the list of our speakers for this master class. These are the topics which will be covered in the master class. GIS and conservation, supervised land use and land cover classification using QGIS, story maps, visualizing geospatial data, humanitarian mapping using OpenStreetMap and QGIS, GIS in bathymetry, current practices for monitoring harmful algal blooms using Earth observation, remote sensing data science for agriculture, OpenStreetMap application in transportation. How to access the videos and learning resources. We will be using the platform Substack for all our communications during this Masterclass 2022. Substack is an email newsletter platform. It is completely free. The links to each class on each scheduled day will be posted via Substack. It will reach your email inbox. Make sure you check your inbox and spam for the mail. Day 1 Masterclass 2022. Supervised land use and land cover classification using QGIS and remote sensing data science for agriculture.
Hello and namaste everyone. I am Kavya Tanna from Gujarat, India. First of all, I would like to appreciate the efforts that have been done by Geosakhi organization to aware people and especially women about geospatial techniques. I feel so proud to be part of it. So I heartily thank Geosakhi for bringing me on this platform as a speaker of Masterclass 2022. I will quickly share my screen. Okay. And yes. Okay. So the topic for today's class is supervised land use land cover classification. As you can rightly see that I have mentioned my email ID at the bottom of the slide. So if you feel any doubt or if you have any query, you can anytime email me and I assure you to give you a reply if I know what it takes to fix your problem. Let's move further. So this is what our class has contents. So today we will see how to download satellite image of Landsat 8, that is a satellite, and the website we will be using, that is USGS Earth Explorer website. Next, we will see that how to do classification and especially how to do supervised land use land cover classification of the satellite that we download. We will then generate a report of the classification that you have done. Let's quickly see a little background of land use land cover classification. So, land use land cover is a basic weapon, I would say, that has occurred to human beings. And with the help of that, we can aware ourselves about the things that is going on a particular land. We can prevent natural disaster, we can protect our environment, and we can manage and plan land accordingly. With the evolution in geospatial techniques, land use land cover is very effective and it helps us monitor the condition and change uh, that is being done on the global surface. So when you hear the word land use, land cover, the very first question that hits your mind is what is land use and what is land cover? So I've given a very simplified definition here that anything, anyhow or any way, if an human being is utilizing a land, is using a land, that is called land use. So anthropogenic activities, that is human caused activities which are done on the land, is land use. That could be buildings, agriculture, playgrounds, buildings, anything. Okay. Land cover, anything that covers the land is land cover. It could be a vegetation, it could be a water body, it could be a grassland, anything that covers the land is land cover. Now, another question that will hit is what is the purpose of land use land cover maps? So, yes, we will be creating a land use land cover map after we generate the report. So, the purpose of land use land cover maps are mentioned here. We will not go deep into the theory because all the theoretical reading materials are always available. So, I'll shortly tell you that it is used for planning, monitoring, and managing. It is used for understanding that how a particular land is utilized. We can use it for forming policies for protecting our environment, for sustainable development. We can study the change that has occurred on the land uh, in past years and throughout the years. We can also launch different policies and programs to save our environment. So we will quickly go with the steps that we are going to see here, and which we are going to perform on this class. And those are, first of all, we will see that we will how to download satellite image, right? As I prior also said that we will be using USGS Earth Explorer for downloading and satellite image. And then we will go into the next steps accordingly, right? So whenever you will open the Earth Explorer, you will be seeing the front page like this. Okay, so I have kept a screenshot here of the screen which you will see when you open Earth Explorer. Right? I'll go and open it here. So USGS, here it is. You have to click the very first link you see. Right. So here, this side, you will, if you are using this for the first time, you will see here log in. I have already made my account here. I have already registered. So you can see my name here. But if you are doing it for the very first time, you will be seeing a tab which has log in. So you have to log in with your email ID and a password. Okay. So once you log in, you will be seeing a page like this. Okay. So I am from India. I'm teaching you something which is from India, right? So I am looking for a place that is in India itself, and it is in Rajasthan. So yes, to find that place, we have two options. Here we see address, right? When you see on these options, you have to choose the second option, that is address/place. Now you have a tab here where you can mention your address or place. So I am looking for a place that is Jaipur. So I will write Jaipur, comma, India, to ignore any further difficulties. Let's see. See, here we have got the latitude and longitude of Jaipur. As soon as you click here, you will be on Jaipur, right? So I am taking the satellite image of entire city. Okay, because we will be doing land use, land cover classification of Jaipur city. So I need to make a polygon, or let's say to select an area to download a satellite image. So now I know that this is Jaipur and this is the city, right? So I will close this and I'll select this polygon tab and I will make a good fine polygon here surrounding Jaipur, right? So we have made a polygon here. We can see the latitude and longitude of all the points that we have created here. Okay. So this is the tab you will see when you scroll down here. That is date range. We will mention the date of the starting date and the ending date between which we need the satellite images. Okay. So let's guess that we need satellite images for the year 2015. So we will start the search from January month. So 01, 01 and 2015. To which month? That is December. So 12, date will be 01 again, and the year will be same, 2015. So we have given the date criteria between which we need satellite images. All right. Now we will fix the cloud cover. That the maximum cloud cover that is okay for us is, let's say, 30, right? 30. Yeah, 30 is fine for us as of now. So we will set the cloud cover 30. All right. Scroll up again. Go to data sets. Here we are especially looking for the images from the satellite lens set. Okay, so we will find our satellite here, and here we have lens set. Go for level 2, collection 2. In that lens set 8, which gives you the current and latest images, right? So we will select Landsat 8, 9, OLI, and class 2, level 2. Collection 2, level 2. All right. Then scroll up again. We have already selected the criteria. There is no need to do any additional criteria here. If you want, you can go through these options, and if you feel any requirement, you can change it accordingly. Otherwise, there is no special need to do any additional criteria. Directly go to results. And here we have around 32 images from the year 2015, January to December, right? So let's go to the last image first and let's check. Okay, so when you want to check if the satellite image covers your desired land or not, we need to see the footprint that is right here. Okay, so this covers my area. Okay, but I don't see it that clear, so we will not select this. Let's say this. Okay, so see, this satellite image does not cover the area we want. I have my polygon here ready, but the satellite image does not cover the complete area that I want, right? You see that, right? So we want to select this image. Let's go to previous and see some more images. Okay, so this is from the month of January. Okay, this image does cover the area which I want. So this is fine for us. The cloud cover is good as well. Okay, this does not cover. This also covers, right? So this is fine. There's not much cloud cover seen as well. So the image is clear. It covers the land, and we will go for the download option. So here you saw the icon which is for download, right? I'll again show you once again. So that is the, I guess, fifth icon. Yes. So the fifth icon that is download options. You have to go in that. You will see product options tab. Click on that. Now here you have to specifically download only the bands which are required for classification. We'll go for band 1. It will take few minutes to download. Band 2, band 3, band 4, band 5, we have band 6, and here we have the last band, band 7. Okay, so we'll wait for few minutes, maybe a minute or two, and we will wait for all the downloads to get over so that we have all the bands. Okay, the downloading is still in process. Okay. Okay, we have 3 bands ready. Let's wait for the other bands to download as well. Okay, so last 3 bands, and then we are fine to proceed. Okay, we are almost there and done. Fine. So we will find these downloads right here. Let's select them. And I have already made a special folder wherein I can save these images. so I can get it whenever I require. Okay, so I have already made these folders. We'll go to satellite images and paste here. Okay, so these images are ready, right? All the 7 bands of the satellite image are ready. Let's go to our presentation. We have completed our step 1. Next is in QGIS, right? So let's open QGIS. This will be the screen when you open QGIS. I am sure you have seen the class from previous year wherein you were taught the basics of QGIS. You were taught to see these menu bars and icons and how to insert vector or how to insert raster and how to install certain plugins like SCP. Okay, so this much I think you all know. So I'm taking it further from here. Okay, so let's insert the raster data. Raster data is our satellite images. So I can go to the place where I saved it, and here they are. So I will select all, add, and close. I see, okay, we don't need this right now, so I'll close this. We'll further work in that as well. So here we have all the bands. You can see that from band 1 to band 7, we have got all the images. Now, we do not need to classify the entire satellite image, right? We need to classify a particular area, that is our vector data. So let's add our vector. That is the shape file that you must be having, okay? Or you can either download it from the websites, or you can also create your shape file or vector layer. If you are not aware about that, we can certainly take that thing as well, probably next year. Okay, that how to create a vector layer or a shape file. So yeah, I have rightly inserted my vector data here. That is, you can see that it is on the satellite image. Now I need to crop or clip the satellite image, and I only want this much area. Okay, so we will go to SCP plugin, go to bandsat, that is the very first option here, refresh, and you will see all the layers have been inserted here. We need to select them. You can select one by one, or here we have this, which selects all this icon or this tab. You have to click it. It will select all the things, all the bands at once. Fine. Add it here and just check the sequence once. So it is from 1 to 7. So I think it's fine as of now. And we will here go to pre-processing, clip multiple raster, and we need to clip by using our vector data. So check this box, refresh it. So you will see that our vector is here. It has been loaded, and go for run. Now you need to save this step, right? So we will go to the desired folder and we will save it. Now let's wait for this step to finish. It's 20% done, and we will wait for it to be 100%. Okay, it's almost done. It will take few minutes to complete the step. and save it. So the 65% done. Okay, so the step is completed. You can minimize this tab for now. Okay, you see, you have got this clip layers on your layer panel, right? You know what is layer panel, right? Okay, so now we only need these layers. We need not need the layers of satellite images. So we will select them and we will remove them. Yeah, we have nicely removed. Now we only have the desired portion of the satellite image. So this step is called clipping. Let's see. Here we have successfully added the raster, we have successfully added the vector, and we have nicely created the clip layer of the satellite image, right? The next step is to create raster bands. So once again, open the tab that you had minimized. Go to bend set again, refresh the new layers that you have created, band 1 to band 7. You need to delete these layers first. Those are the satellite bands. You have to remove them. And yes, we are sure. Select them. Select the new clip bands. Add them. Check the sequence ones, that is band 1 to band 7. It is right there. In the bottom of this dialog box, you will see that you have an option here, create raster of band set, right? That is stack bands. So you have to check this box, run. You need to save this step. So go to the desired folder wherever you want to save, click it and select folder. These are being saved and it is done. Okay, I will uncheck these layers so that we can see it. Okay, so this is how it looks, right? But it is very difficult for us to identify that which is which class. We need to divide this portion of the land into 5 different classes. That is how it is done, right? We need 5 different colors to identify that which color gives you which class. So here we have RGB box, wherein you need to give a code, or let's say the band combinations. You can give different band combinations, let's say 4, 3, and 2. That will give you the natural color image. Okay. Similarly, what greatly works for me is band combination of 7, 6, and 4. Okay. Or you can also go for 5, 4, 1. This gives you another image. So you can choose the band combinations of your choice. 5, 4, 3 is also one option. Okay. Let's go for 7, 5, and 4. See, you see the different colors, which gives you the understanding of different classes. So I think this will go for me. Here we see that the purple colored, or say the lavender color, is for the built up. The light green gives us agriculture. We have some dark green here, that is the deep vegetation. And the pinkish tone here gives us the open land, which is very, very light. You can see that. and we have very less amount of water body, I guess. Otherwise, the dark blue blackish color goes for the water body. I guess this much part will be the water body. So, okay. So we need to create a training input for classifying the image. For that, we need to open SCP doc. So go to View, Panels, SCP doc, right? Here, go into training inputs. You need to save the step first. So we will go to the desired place, name the file, and save it. Okay, so you have the desired location here. Now we need to name our classes. So my first main class would be vegetation. I will give the same name to the class ID as well. So I will select and I will paste. Okay. Okay, so now we need to create ROI. So you have to select that. You have to select this ROI, which will create polygons. So you have to select pure colors of that class for the software to identify the area of that particular class. So let's find the pure color pixels of vegetation. I told you prior that we have some dark green patches here, right? So we will be selecting pure colors of vegetation. Okay. Create a polygon, and when you want to close it, go for a right click. This one is fine. Select everywhere where you find that there is vegetation and pure color seen. Okay. You can select 6 to 12 pixels which are pure of that color and gives you an identified color pixel. Yes, so I mean, these are fine. You yes, we have lost it. Here. And here also we have vegetation. So these pixels are fine as of now, I guess. Okay, we have selected the pure colors of vegetation that we see, and we have made around 4 to 5 polygons for it. Okay, so for saving it, you have a button here. You just have to click to save temporary ROI. Okay, so it will be created here. Let's wait for this step to finish. Then we can add for the another class. So we will go for another class. Let's name it agriculture. Let's find pure colors of agriculture. We will be a little quick now. Here I see agriculture. Almost we have these colors everywhere seen, right? Here also we have pure pixels. We are saving this color. I would suggest you to make more pure pixel polygons to get a good classified image. So make sure you do not mess up here and you create as many polygons as possible. Okay. So I guess this much are fine as of now. We are a little in a hurry. So we will save it. And let's make it for built up as well. So you have to select the pixels which are pure built up. So these all the purple color shades. I'm sorry. All the purple color shades are built up areas. Okay, you have to select those colors. And you have here dense population, dense built up, I would say. Jaipur, I would say, is a tourist place. So there are a lot of people every year visiting Jaipur, and we can see that, right, here from the built up, that it is really developing itself. It is also known as Pink City, I would say. Jaipur is known as Pink City and it is located in Rajasthan. So, yeah, we can see the development that is massive and built up, especially. Okay, so we have almost made the polygons for built up. Let's save them. Okay, next we will be taking for water bodies. So we have little water body here. So let's quickly select the pixel for that. And then move ahead. Okay, so we have water body here. Have it here somewhere. It's quite dark. Okay, this much is fine, I guess, as of now. Let's save it. I would again suggest you to create as many polygons so you get a better classified image. Okay, we are a little in hurry here, so I'm making few polygons. But if you are doing and if you want to do it very nicely, you have to make bigger and of more numbers. Okay. Okay, so we will create the polygons for last class, that is open land. Okay, so this gives us open land, right? Somewhere you will find that the shade of a particular color is different, but there is no problem. You just have to see that you select the shade of that color nicely so that you don't miss out on the classification part. So we also have some pink here. Okay, selected. Here also we have it. See, the shade is lighter, but the color is still pink. So it gives us the open land. Here also we have some. Let's do it. I think these are fine as of now. I've tried to cover all the shades of the open land so that we don't miss out. Yeah. Okay. Let's save it. You need a lot of patience in doing classification, don't you? Yeah, so it's ready. And there we go for SCP here. Go for band processing, classification, and you will be having it. Okay, so check this MC ID because we are dealing with main class ID only. Here, go for maximum likelihood and go for run. You have to save this somewhere, just like other steps. So I will only name it classification. And go. Let's wait for it to be saved and create. Okay, so minimize this as of now. We have got a very good classified image here. We will uncheck all the undesired layers so that we get it here. Fine. Now we need to give defined scientific colors. You need to remove this because it is the error which QGIS always gives. It is not required, so you have to select this and remove. Fine. Now we will give to the scientifically decided colors for various class. So for vegetation, we will go for dark green shade. Yeah, this is fine. For agriculture, we can go for yellow or let's say lighter green shade. Light green is fine, right? And built up, we will go for, let's say, purple shade. Yeah. For water body, we will have a blue color. And for open land, let's go for sand color, I feel. Yes, this is fine. It seems fine, right? So let's apply and okay. So we see here, right, that if you are not satisfied by the color, you can still change them, okay? You just have to right click on classification, go to properties, and you can choose the colors. You just have to double click here on the color and you can change whatever you want. See, for example, I want to change this color. I'll choose a lighter shade. I'll select it. And apply and okay. Okay, so I've got a lighter shade. I cannot see the water body so clearly here. A lot of water bodies there. So, okay. So, so many resorts are there in Jaipur. So I guess that is one of the reason. I don't know. Okay. So this is what the classified image shows us. All right. Um, now let's create a report for it. So we will go again, SCP, or you can open this tab, which you have minimized. Okay. You have to go for post-processing, classification report, select, refresh. So you will automatically select classification, run, and you have to save the step again, just like you have done, and you will be saving it here. Let's name it LULC report. Okay. And let's see. It is created. You can see that, right? You have percentage here and you have area here. Your class 1, 2, 3, 4, 5. You have the area, you have everything. Okay. So with percentage, you have got your report. You have already saved it. You can anytime open it from the desired save folder and you can access to it. Now, as I have said that we will be creating a map. So go to project on the menu bar. And you have to open this new print layout. Okay, you have to name it LULC map or anything you wish for. Okay, and a new page will be opened. So you have to go through these icons once and just see that what they are for. So we will create a map. So this is for map. Add map. Make a good fine square here. Okay. And you have map. I will reduce its size. Just a minute. Fine. We still need to reduce. Okay. Okay, or let's say you can play with this and you can do as required, but make sure the map comes. Okay, this is fine for now, right? Okay. Next, we will go for title. Okay, so you have to create a title here. Name it land use land cover map of Jaipur. Okay, you have to select the font. Maybe let's do it 24, I guess. Yeah, 24 is fine. Select OK. Scroll down, select center, keep it in the middle. If you want, you can always increase the size and do as per required. Okay. We can give a frame here of title. This is done. Now, always there are few things to be noted that a map always has an arrow directing towards the north. So you have to do an arrow here, add the north arrow, take it and place it. It's done. Always there's a scale, so select scale and place it here. Okay, the scale, you can make some changes if you require. So let's say 2 for left and 4 for right. Okay, so we have a scale here. We have an arrow here. All we require last is legends. So it will come. It will show everything that is in the layer bar. Okay, so scroll down here and check this box. Only show terms inside the linked map. So you will get only the desired legends here. So this is how you can give a frame to your map. Fine, so it gives a good finishing look of your map. You can save it by export image. You can go for the desired location and save it. Okay, this is image and save. Okay, so here, let's come. So we have done everything that is mentioned here. We saw, we noted the things, and that brings me to the end of this session. I really hope to see you all again next year maybe, and keep trying classification. Even if you fail, don't be disheartened, don't be sad. Your failure gives you the true feeling of how the success will be when you get it. Okay, so you can only feel the sweetness of success when you have tasted the bitterness of failures, right? So I'll see you all the best. And if you feel any query, you can email me on the given email ID. So, okay, thank you and bye-bye.
Hello, women in Geospatial. I am Paramita Ghosh, Remote Sensing Data Science, Test of Corteva AgriScience India. I have done my master's in geoinformatics from IIT Bombay, and I was Young Ambassador for German Academic Exchange Services New Delhi for 2019 and 2020. I am also the recipient of Green Talents 2020 Award by Federal Ministry of Education and Research, and also awardee of Google Summer of Earth Engine 2019. In this masterclass, I am going to talk about remote sensing data science for agriculture. First, let us understand what is satellite remote sensing. This is the use of satellite-borne sensors to observe, measure, and record the electromagnetic radiation reflected or emitted by the Earth and its object, and subsequent analysis of this recorded information. Now, let's understand how it works. First of all, an energy source illuminates the Earth, and then this radiation travel through the atmosphere and interact with different objects of the Earth. And this energy then get reflected or emitted by the objects of the Earth. And this reflected and emitted energy is recorded into the satellite sensor. This recorded information is then transmitted to the ground station where it is being received and processed. And this recorded data is further interpreted and analyzed by the analysts and scientists, and then they convert this recorded information into a meaningful application. This is the full circle of how satellite remote sensing works for developing different agricultural applications. So the application on remote sensing of agriculture, the imagination is the limit, how we can leverage the information that holds in the satellite images to create a meaningful solution for agriculture. To name a few, application, they are agriculture land monitoring, crop classification and area estimation, crop yield estimation, then agriculture drought assessment and monitoring, crop health monitoring, soil mapping and monitoring, then pest and disease detection and incident forecasting, to name a few. Now let's understand how this recorded information is giving us the insight about different biophysical and biochemical processes of crop. So the energy is captured in different wavelengths of light. First, from visible, the energy reflected from the visible to NIR range give us information about the leaf vigor of the plant. And in the infrared zone gives the information about the photosynthesis process in the crop. Whereas in the thermal infrared zone gives us information about the crop canopy temperature and evapotranspiration. Then moving to the microwave wavelengths, the radar backscatter are giving information about the top canopy biomass. And for passive microwave, it is giving information about the canopy column water content. Now you see the different wavelengths of light is giving us insight about the different aspect of crop. And these informations getting integrated into model for developing different kind of agricultural application. Here you can see the spectral reflectance curve of vegetation. Here you can see in the visible range of light, we are getting information about the chlorophyll absorption by the crop. And in near infrared, we are getting information about the cell structure of the crop. And in the shortwave infrared zone, we are getting information about leaf biochemical, protein, lignin, cellulose, and water content. All these informations are very critical when it comes to develop application and understand the processes in agricultural crops. Now here you can see the spectral reflectance curve is slightly different for different crop types. The shape of the curve is similar, but the values of reflectance, depending upon the biophysical, biochemical processes of the crop, the values of reflectance are differing. And this is how we can capture different and identify different crop types from using satellite remote sensing images. And also the reflectance values in different spectrum give us information about crop health, crop yield, and if any kind of crop stress exists on field. Now let us understand what are the basic building blocks of developing a remote sensing data science model. First piece is data collection. Now we can divide data collection into two components. One is data collection by the satellite, where it records the reflected or emitted energies by the earth elements. And then this is converted into the satellite images. And the second component of data collection is ground truth data collection. So this part is very important and useful for developing a data science model. So in data collection, farmers, all field technician collects the geo coordinate of field along with the different information from the field depending upon the project need. For example, the field technician collect the plot boundaries, then crop type information, crop quality, crop volume, crop yield, and if any disease stress or water stress exists, the data about irrigation. So all the factors are recorded depending upon the need of the application development. Then once this data is collected, this data is being used for satellite image data analytics. This ground truth data, the plot boundaries or geolocations are used to extract the images from satellite features and then analyze with the ground phenomena. And depending upon this preliminary data analysis, the features are selected for model development. Some example of the features are spectral information, morphological profile, texture features, to name a few. Then these input features, along with the ground truth data of crop type, crop yield, crop growth status, etc., are being fed into the machine learning model, and the model is being trained and tested on the ground truth data. And finally, the application is built, like crop classification, crop yield estimation. So this is a broader level overview how a data science model is being developed using satellite images. Now let us dig deep into the model development. So today I will be sharing with you my strategy for developing a crop yield estimation model. So I have developed this during my master thesis project in collaboration with TU Darmstadt, Germany, and Hessische Statistische Landsmatte. So first of all, let us understand the first step, that is the satellite image processing. So in this project, I have used two types of satellite images. One is synthetic aperture radar that is provided by Sentinel-1 satellite, and another is optical multispectral satellite images that is provided by Sentinel-2. Now these images were processed using the SNAPS software. For SAR data processing, first border noise removal was performed, then sigma naught was calibrated, and finally the terrain correction was applied. After all these steps, the Sentinel tiles covering the entire study area were mosaiced. Now, for optical data processing, Sentinel-2 has bands at different spatial resolutions. So first of all the bands were resampled at single spatial resolution, that is 20 meter, using the nearest neighbor resampling. Now, spectral subsetting was performed to select the bands we want to use further in this development project. And then spatial subsetting was done to select the study area out of the total Sentinel image scene, and all the tiles covering the study area were mosaiced. Now, finally, our Sentinel-1 SAR and multispectral data is ready. Now, we have to co-register them for extracting features and relating it to the ground truth data. Now, for core image co-registration, ground control points were selected, and then nearest neighbor resampling were applied to co-register these two datasets. And then image features were generated from Sentinel-1 and Sentinel-2 images. This is the table of the satellite-derived feature used in this project. So the objective of this project was to evaluate if we can develop a reliable crop yield estimation model using only the satellite image derived feature, which represent different biochemical and biophysical processes along with the structural information of the crop. So, depending upon the knowledge of remote sensing of vegetation, these input features were selected. Now it's the time to prepare the ground truth data. The ground truth data was collected by Hessische Statistische Landsmatte, Wiesbaden, Germany. And this dataset was used for the model calibration and validation. So the crop yield data was collected as a point data, and along with that, we had the crop field entire boundary. Now for this project, we have to club them together, the point yield data and the field boundaries. So we have used QGIS spatial analysis tool content method to combine the yield data and the field polygons. Now, to ensure the pure pixel out of each crop type field, we have applied a buffer to the crop field boundaries. And after trial, we have found out that minus 14-meter buffer is suitable for our study. Then the buffer ArcGIS Spatial Analyst buffer tool was used to create the buffer and then refine the field boundaries. So finally, a zonal statistics of these field boundaries were prepared out of the satellite images. Now for satellite image feature extraction, we have 4 types of crops in this project. So to derive the feature for individual crop type, we have used the satellite image crop map of the state and masked the satellite images for different crop types using ArcGIS data management tool. And finally, the feature set were extracted and then merged with the ground truth yield information using ArcGIS zonal statistics as table tool. Now the crop specific input feature is ready to be fed in the random forest regression model. Now let us understand the core model of crop yield estimation. Here we have selected the best set of feature using genetic algorithm. Now let us first understand what is genetic algorithm. This is a mathematical model based on the famous Charles Darwin law of natural selection, that is survival of the fittest. So here in this project, we have selected the input feature based on the a priori knowledge of remote sensing of vegetation. Now we want to select crop specific feature which are the best predictor of crop yield. So for this, we have applied genetic algorithm in the feature set. So first of all, we have initialized the random population out of the entire feature set. And then a fitness function was declared and evaluated. Here the fitness function was minimum mean absolute error of the predicted and the actual ground truth data of crop yield. Then the selection, crossover and mutation happened, and after that the stopping criteria was evaluated. If the criteria met, then the feature came into the best input feature set. If not, then it again went back to the evaluation. That's how we found out the best input feature set for our regression model. Now, the crop yield data was split into 70% and 30% as training dataset and testing dataset. The random forest regression model was trained on this 70% dataset. Now let us quickly understand what random forest regression is. This is an ensemble of trees where we have n observation and m prediction. Then using the bootstrapping different samples, the trees has been created and each individual tree predicts one regression value, and the average of all the trees in this ensemble meant the final prediction was made. And then the model was optimized using hyperparameter tuning. What is hyperparameter tuning? This is a problem of choosing the best set of hyperparameter for a machine learning model, which gives the reliable performance. Then the accuracy were validated, tested and validated using training and testing ground truth dataset. And after achieving the reliable accuracy, the crop estimation model was finalized. Now, let us look into the result of feature selection. The features which were selected most frequently were finally considered as the best set of input parameter for all the different type of crop. Here we see the selected best features were different for different type of crop. That means we cannot generalize some feature based on our proven knowledge of remote sensing of vegetation for all the crop. That's why crop specific feature selection is very important, and the result is pointing us towards that. And for hyperparameter tuning, we have optimized the model on the number of trees, depth of trees, sample at leaf node, and sample for splitting. And the criteria of hyperparameter tuning was the minimizing of mean absolute error between the predicted yield and the observed yield. Depending upon the minimum values of MAE, the number of trees, depth, leaf at sample node, and the samples for splitting were finalized for the model. Now let us understand the results of model calibration and validation, that is training and testing. So we have compared two types of model. One is baseline random forest regression, where we have used all the input feature for all 4 types of crop, and the optimized random forest regression, that is we have done crop specific feature selection by genetic algorithm and use it for model development. So here we can see in case of baseline random forest, where we are trying to generalize that the same feature will be a good predictor for all the crop types, is not holding true. Here we can see that the models are overfitting for most of the cases, whereas using optimized random forest and using the genetic algorithm selected features are giving us more reliable result, where the accuracy on training and test data set is similar. That means the model is reliable. So after doing all this exercise, we have finalized the optimized random forest regression model crop wise and applied this data model to the crop mass we have generated for each type of crop. Here you can see some field level crop yield images from this crop estimation model. And you can see that the interfield crop variation is very well captured by the machine learning algorithm. You can access the source code of this entire project here in the GitHub repo. Now, I want to share with you some learning resources for theory of remote sensing, accessing the open source remote sensing data, popular software for satellite image processing, open source ground truth data for your model development, and the learning community for remote sensing data science. And you will find in GitHub a lot of good remote sensing data science project and their code. So if you are a beginner, you can absolutely start learning from the open source available codes. So here I have given you the resource for getting started with GitHub account. And now let's check out how you can access the GitHub repository and try out the existing code for data science model development. Here is my GitHub repo for crop yield estimation model. So here you can click on the code and copy this HTTPS link and clone this repo into your local machine. Let's see how to do it. Now you can open your Git bash and clone the repository using the HTTPS link. Now let's see how to use it. Yes, now we have copied the HTTPS link. Let's clone the GitHub repository. So for that, we will use the command git clone and paste the repo we have just copied and then hit enter. Now, this repo in the GitHub will get cloned in your local computer. Let's check this out. Here in your local computer, you will see the cloned repo. And let's check what is available in this cloned repo. So all the notebooks, dataset, documentation, whatever is available in the GitHub repository, all will get cloned in your local computer. Now you can use this Python files in your local Python environment and start learning from it. Let's check how you can upload this file from the clone repo of GitHub into your local Python environment and start learning from the existing codes of GitHub. Yeah, so now let's upload the Python notebooks which we have in our clone repository. So let's upload the model for winter barley yield estimation. Here we have the notebook of winter barley yield estimation. And now you can read the entire notebook and check out the Python code for this model development. Likewise, you can clone any of the repository available in GitHub. And there are lots of good repository available in GitHub for learning the data science modeling. So now you have all the resources with you. Start practicing and coding and learn the remote sensing data science model development for agriculture. Thank you, everyone. If you have any question, you can find me at my LinkedIn, ResearchGate, and also via my email. Thank you, everyone.
Miss Kavya Tanna. She is a PhD scholar in Saurashtra University of Gujarat. She has done her master's in climate change and received a gold medal in her MSc degree. She has recently received Best Paper Award from Bishop Harbour College, Tamil Nadu. She has worked for society and its upliftment for as many aspects as possible. Ever since she learned GIS, it has been her dream to pass on this knowledge to people, and especially girls who are unable to learn it because of some reasons. So we are so thankful for her for giving us this wonderful presentation. Paramita Ghosh. She is working as a remote sensing data scientist at Corteva Agri Science India and an alumni of the Indian Institute of Technology, Bombay, India. She is proficient in developing agricultural applications from satellite and other sensor data. Join us and grow your professional network. Register for our speaker database and show the world the great work you do. And put yourself out of the comfort zone from time to time. Get mentored and be a mentor and support the community. Speak for yourself and the diversity that will be a factor of change in the future. Thank you for joining us on day one of Masterclass 2022. Please join for the next day and we hope you had a great time. Thank you.